Hey there, and welcome to this explainer. When we look at those massive steel cargo ships crossing the world's oceans, they seem totally invincible, right? But they actually have a critical, highly exposed vulnerability out there on the weather deck. Their hatch covers. Today, we're taking a high-stakes look into the complex world of hatch cover mechanics. We're going to explore the key parts, the strict securing procedures, essential maintenance, and the exact science of testing what is, quite literally, a very thin line between safe cargo and total disaster. Let's get right into it.
So think about this number for a second, 1/3. It's actually staggering to realize that a full 1/3 of all maritime insurance P&I claims are due to damaged or lost cargo. The financial stakes we're talking about here are absolutely massive, and crazy enough, it often comes down to the failure of just one protective system on the deck.
Okay, let's dive into this. It's super easy to look at a ship and think of hatch covers as just, big, static metal lids. But honestly, thinking of them as static is a really dangerous misconception. They are highly dynamic systems forced to operate in a literally hostile marine environment. A single moment of careless maintenance on an otherwise perfect hatch cover, that can compromise the stability of the entire ship and destroy a multi-million-dollar cargo in just minutes. So here is our roadmap for today. First, we'll cover the weather tightness challenge, then we'll break down the anatomy of rolling covers. After that, we'll walk through the specific securing procedure, lay out the essential maintenance protocols, and finally, look at testing weather-tight integrity.
Starting right off with part 1, the weather tightness challenge.
Before we start looking at the heavy machinery, we really need to know our ultimate objective. The 1966 standard defines weather tightness as the condition where, in any sea conditions, water will not penetrate into the ship. Now, I want to be super clear here. This is not some lower standard than being watertight. It's actually a highly specific requirement because the ship has to maintain this seal even during the intense relative movement between the hatch covers and the coamings, which is that raised rim around the hatch. And listen, failing to meet this standard puts ship owners in serious legal peril. As legal precedent clearly points out, you generally cannot rely on the peril of the sea defense in a cargo damage claim if you don't have hard evidence of diligent maintenance. Basically, you can't just blame a rough ocean if your inspection paperwork isn't totally flawless. So weather tightness is really a state of dynamic geometry. As a massive steel ship bends, twists, and flexes in a rough seaway, the hatch cover essentially has to float on top of it. The objective is to defend that incredibly thin line where the steel compression bar and the rubber seal meet. If that precise geometric relationship gets thrown off, the line breaks and the ocean pours in. Moving on to part 2, the anatomy of rolling covers. Let's break down this physical arsenal. Rolling covers feature a pretty complex system of parts. On one hand, you have securing mechanisms like your quick-acting cleats and top cleat assemblies, and those act as the locks for the shield. Then, on the other hand, you have the drive units, like the rack and pinion system, acting as the muscle to physically roll those heavy panels open and closed. Every single one of these components has to be perfectly aligned for the whole shebang to work. All right, part 3, the securing procedure. All of this heavy machinery is completely useless without absolute human precision. And here is a wild fact. Screwing cleats down hard will absolutely not ensure weather tightness. I know, it sounds counterintuitive, but it's a dangerous, widely held myth in the industry. Actually, no amount of tightening the cleats beyond their correct position will improve the seal. Why? Well, because the covers are factory tested without engaging the cleats at all. The sheer weight of the hatch cover itself is enough to create the required rubber gasket compression. The cleats are literally only there to protect against excessive movement when the ship rolls. So you're probably wondering, how do you correctly establish that baseline compression? Well, it comes down to a highly specific 6-step securing procedure. 1. Close the hatch and secure it for sea. 2. Place the cam of the cleat in the socket as if you're going to lock it, but leave it unlocked. 3. Adjust the locking nut until the compression washer just barely touches the underside of the coaming. 4. And this is absolutely crucial, turn the nut exactly 1 full turn to achieve the desired tension. 5. Do not over-tighten it. And 6. Protect the thread. So really, the key takeaway here is that micro-precision of a single, exact full turn. Nothing more, nothing less. Let's jump right into part 4, essential maintenance protocols. Maintaining this dynamic geometry is an ongoing battle against wear and tear across several critical points. For your rubber seals, you've got to constantly check their contact with the compression bars. For the cross joints, you're inspecting for structural corrosion and proper alignment. Hinges need their pins regreased, and you have to check for blade cracking. And for the steel-to-steel inner panel blocks, you want to check the locators and top plates for wear. Oh, and a really quick note from the experts, using hatch cover tape offers a total false sense of security. It's just a temporary fix, definitely not a replacement for this rigorous maintenance schedule. When this maintenance gets neglected, you rapidly run into these common but catastrophic defects. We're talking worn wheels, damaged trackways, hydraulic leaks in the pot lifts that cause uneven lifting, insufficient hydraulic pressure, worn rack and pinion gears, and misaligned cleats. Any single one of these defects throws off the incredibly tight tolerances required for a good seal. Just one moment of careless maintenance here can compromise the entire cover. Finally, Part 5, testing weather-tight integrity. After securing and maintaining the hatch, the crew has to empirically prove that the defense actually holds. Now, traditionally, the industry relied on methods like looking for daylight in a pitch-black hold or the high-pressure hose test. But ironically, the hose test poses a massive risk of flooding the cargo if there actually is a leak. That's exactly why the industry is moving away from those older methods and strongly favoring modern advancements, specifically ultrasonic testing. During an ultrasonic test, a transmitter is placed inside the cargo hold, switched on, and then the hatch covers are fully secured. That transmitter emits ultrasonic waves that will leak through even the absolute smallest structural apertures. Then, an operator out on the deck uses a receiver to detect any of that high-frequency sound leaking through the seals. The advantages here are just incredible, which is why it's the preferred testing method. It identifies the exact location and extent of a leak. But even more importantly, it indicates the unseen compression status of the rubber seal. If the compression is good, you know for sure the rubber will be able to compensate for the ship's movements out at sea. Plus, it's a super quick, one-person operation, and best of all, it can be done perfectly whether the hold is totally empty or packed to the brim with valuable cargo. So we've broken down the key parts, the strict procedures, the maintenance, and the testing. But I want to leave you with this final thought. As ships grow larger and seas grow rougher, is your thin line of defense truly secure without the rigorous documentation to prove it? Remember the ISM code. All this mechanical knowledge means absolutely nothing if you don't have the maintenance logs, the test reports, and the work specs to prove your due diligence. Ultimately, it all comes down to human responsibility. Thank you so much for joining me on this explainer. Keep learning out there, and I'll catch you next time.